Hello everyone. In this video, I'm going to talk about some of the key concepts of the blockchain technology. Before starting, I would like to quickly introduce myself. I'm Amrisha Kakoti and I'm working as a software engineer at Kpro Solutions Private Limited. Kpro is a leading provider in Datalake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile applications development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are: what are some of the key terms that we use in blockchain? How does a transaction happen in blockchain? Which will include what is the cryptographic hash function? What is public key cryptography? What are digital signatures? What is a peer-to-peer network? What are block and miners? What is nonce and proof of work? What is the block's data, that is the transaction list, and what do you mean by the mining reward? So let us start with what are some of the key terms that we use in the blockchain technology. So the first one is Bitcoin. So this Bitcoin is a well-known cryptocurrency which is basically based on the proof of work mechanism of blockchain. The second one is block. So this block is nothing but a record book where all the transactions are maintained chronologically. The third one is block size. So this block size is the amount of data that can be stored in a block. So for example, the block size in Bitcoin blockchain is 1 MB. So it can hold one transaction of size 1 MB or multiple transactions whose sizes sum up to be 1 MB. So this is the block size. The next one is confirmation. So this means that a transaction is successful and got added to a block in the blockchain. The next one is consensus mechanism. So this consensus mechanism is a process by which new blocks are added to the blockchain. So it includes various algorithms like proof of work, proof of stake, etc. The next one is the hash function. So this hash function takes an input data of any length and provides an output data of fixed length. The next one is hashing. So this hashing is a one-way non-invertible function that maps a set of inputs to a set of outputs. The next one is miners. So these miners are nothing but the machines that carry out the transaction validation process and adds them to the blockchain. The next one is mining reward. So the miners receive a certain amount of relevant blockchain's coin when succeeds in adding a block to the blockchain. So this is what is meant by the mining reward. And the last one is wallet. So it is a software in which one's cryptocurrencies can be stored. So these are some of the key terms that we'll be using while talking about the blockchain technology. Next, let us see how does a transaction happen in blockchain. So to understand how a transaction happens in blockchain, we need to first understand the following terms, which are: what is the cryptographic hash function? What is the public key cryptography? Digital signatures, peer-to-peer network, block and miners, nonce and proof of work, blocks data, that is the transaction list, and the mining reward. Now let me explain you all the terms that I mentioned on this slide. So let me start with what is the cryptographic hash function. So this cryptographic hash function is a mathematical method which takes an input data of any length, processes it, and generates an output data of fixed length. So the properties of this hash function are: firstly, it is impossible to guess the hash value of a particular input. So to find the hash value, we have to run the algorithm. The next one is that it is deterministic. That is, it will always generate the same hash for a particular input. The next one is that it is impossible to guess the input based on the output hash because the hash is always of the fixed length irrespective of the length of the input. And the last but not the least is that all hashes are distinct. That is, no two distinct inputs can generate the same hash. So this is all about this cryptographic hash function. Next, let us see what is the public key cryptography. So in the public key cryptography, the data is encrypted by the sender using the receiver's public key. So for example, if A wants to send $10 to B, so in this cryptography, that is the public key cryptography, A will encrypt this transaction using B's public key, and this can be decrypted only by B because only B has knowledge about its own private key. So once the data is encrypted, it becomes illegible to others. Thus, as mentioned, it can be decrypted only by the receiver's private key. So normally these public and the private keys are generated on the device who possesses the private key. So this is basically what the public key cryptography is. Now let us see what this digital signature is. So to sign a document digitally, we need the document itself and the private key of the sender who is sending the document, and to validate the document we need the signature and the public key of the sender. So for example, now you see here, for example here A wants to send 10 bitcoins to B. Okay, so now what A will do is that A will find the hash of this transaction. So A will hash this transaction and will find the hash of this transaction and encrypt it with its private key. And also he will append this entire thing, whatever he found the result, with the hash. So he will have the hash with the digital signature. So hash plus the digital signature. And then he will broadcast it to the network. So when the transaction reaches to B, he will extract the digital signature and decrypt it with the public key of A. Okay, so B will now extract this digital signature from the hash and decrypt it with the public key of A. He will also extract the original hash from the rest of the message. So he will also extract this hash from the rest of the message, and after decrypting this digitally signed transaction, he will get the hash, right? Because A initially hashed this transaction and then encrypted. So after decrypting this digitally signed transaction, he will get the hash. And if these two hashes match, then the transaction will be authenticated and then the transaction will be updated in the ledger. So this is basically what the digital signature is. So next let us see what is this peer-to-peer network. So this blockchain is nothing but a network of participants called nodes. So all these participating nodes agree upon a certain rules called protocol regarding submission and sharing of data among each other. So here all the participating nodes enjoy equal power, and all the nodes in the network is connected to every other node in the network. So this is basically what is meant by peer-to-peer. And since there is a connection between every node in the network, hence there is no need of any central authority. So this is basically what the peer-to-peer network is. Now let us talk about what is a block and who are these miners. So a block is nothing but a record book where all the transactions are recorded chronologically. So this block consists of two main components, that is the block header and the data. So this block header consists of various fields like the version number, timestamp, Merkle root hash, hash of the previous block, etc., etc. So if you want to know more about this block header, you can follow my first video of the series of videos where I have explained about this block header. And this data is nothing but all the transactions that are listed in this block. So since these blocks contain transactions, so they are broadcasted in the network in order to be validated by all the nodes present in the network. So the machines that carry out the process of putting all the transactions in a block and finally creating a valid block are called miners. So on successful creation of a block, these miners get rewarded with some amount of the blockchain's cryptocurrency. So this block header has a field called the hash of the previous block, which helps in forming the chain by pointing to the previous block of the chain. So this is a set in a field called hash of the previous block in the newly formed block header. So this is all about what a block is and what is miners. Now let us see what is nonce and proof of work. So the hash that these miners are trying to find in order to create a block should be less than the target hash. So this target hash is set by the cryptocurrency network, and both this hash that the miners are finding and the target hash set by the cryptocurrency network are both 256-bit integers. And there is a field in the block header which is called the difficulty, and this target hash is computed from that difficulty. Next, there is also another field in the block header which is called nonce, which is nothing but a random number, and this nonce is used by the miners to get the required hash, which should be less than the target hash. Now if the hash that these miners find is not less than the target hash, then what these miners do is that they simply increment this nonce value. So basically these miners play around with this nonce value in order to get the required hash. So this is basically what a nonce is, and all the work that a miner is doing in order to get the required hash is called the proof of work. So this is all about nonce and proof of work. Now let us see what this blocks data or what is this transaction list is. So this transaction list, or the way the transactions are maintained in a block, has great impact on the block header. So even if the way the transactions are entered in a block is altered, it changes the block header. So this block header has a field called hash of the Merkle tree, which changes if any change is done to anything which is maintained in the block. And so this hash of the Merkle root is nothing but hash of all the transactions that are maintained in the block. So this is basically what the transaction list or the blocks data is. Next, let us see what is the mining reward. So as we have seen, for the contribution of the miners in creating and validating blocks, they are rewarded with some amount of the cryptocurrencies. So in the blockchain Bitcoin, so the miners who successfully submit a block get a reward of 12.5 Bitcoins. But the amount keeps reducing, and it will reduce further in the future. So this is basically what the mining reward is. Now let us quickly have a recap of all the topics that we have covered in this video. So in the beginning, we saw what are some of the key terms in blockchain. Then we saw how does a transaction happen in blockchain. Then we saw what is a cryptographic hash function. Then we talked about the public key cryptography. Then we talked about the digital signature. Then what is a peer-to-peer network. Then we talked about the block and miners. Then nonce and proof of work. Then what is blocks data, that is a transaction list. And finally the mining reward. Thank you for watching this video. In the next video, I'll be talking about the different approaches to consensus that will include proof of work, proof of stake, BFT, that is Byzantine fault tolerance, DPoS, that is the delegated proof of stake, POB, that is the proof of burn, proof of activity, and finally proof of capacity. Kindly provide your valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in your project. You may write to us at feedback@kpro.co.in. Thank you very much. Let's keep learning.